derivatives like derivative of cosine theta equals minus sine theta, derivatives which have a positive expression on one side of the equation and a negative on the other. The solution again is the veritable deficit. Instead of a change of sign, it's simply a subtraction from whatever value there was before in the rest of the equation. Chapter 15 shows that the real system cannot change its heading. The veritable system must. The principle of reflectivity cannot function in the shift from counterclockwise to clockwise. It is in this chapter that the different ways that the two systems handle negativity is brought to a state of maximum clarity. Now, I'll explain that some more later. Chapter 16 shows the mistake made by Sir William Hamilton as he tried to raise vectors upon the basis of real numbers. His system, however, may be adjustable to variable numbers, and this was shown to me by somebody here. Appendix B presents an earlier attempt Sir William Hamilton had to explain the square root of -1 without leaving the realm of real numbers. His device was a number couple, which does not answer the requirement that it be a single number. It's shown to rest upon a radicalization of the Kantian argument. That appendix follows Appendix A. Chapter 17 shows the essential meaning of the veritable system. Direction is a fundamental attribute of space. In the veritable, you might say, well, how could it be? Well, if you notice when Euclid defines an angle, he uses the word inclination. He doesn't define inclination. It's just a synonym for direction. And it isn't necessary that he define every term, because everybody understands it. Why? Because it's a fundamental attribute of space. In the veritable system, the concept of direction is used in its purity, unblemished by subtraction. The real system cannot have a real negative square root because it has no substance apart from the positive. In the real system, the negative is really a diminution of the positive. And you can see this most clearly in the Fahrenheit and Celsius scales. Their zero could be placed differently. The Fahrenheit is based, if you recall, upon a mixture of water and ice. And the ice could be a little bit different. And the Celsius is based upon standard pressure. But this pressure could have, instead of 360, it could have been 359 or 361. Because your standard pressure is a convention. It's close to actuality, but it's a convention based upon measurements of air pressure primarily in Europe, maybe 150 years ago. So it could have been a little bit different. And in the Celsius scale, as we know, it can be replaced by the Kelvin scale, which is an absolute. It is an absolute number. It isn't a sine number at all. Now, the real system cannot, as I said before, have a negative square root because it has no substance and positive. In the real system, the negative is really a glorified minus, a lesser form of the positive, not an independent axis connected to the positive to a neutral point. The variable system is not dialectic. If the real system would be compared to the paying of a debt, the total difference between the two axes in the variable system can be likened under morality. Knowledge of the variable system corrects some of the unreality critics have found in modern mathematics. The gateway is thrown open to some possible advancements in mathematical and physical science. Conclusions. The variable system can do things that the real system cannot. It can have negative square roots. It is more precise in the determination of quadrants and coordinate geometry. It can handle paths and therefore circuits with better reason than can its rival. It can do other operations discussed in the course of the book, yet it can handle logarithms and infinitesimal calculus as well. Knowledge of it reveals the character of imaginary numbers, a character which is still a mystery to people working solely within the real system. The real system can be viewed as a locomotive. Now, starting from the positive axis, suppose it were to back up sufficiently. If it does enough, it will subtract enough from the positive to reach zero. Now, what happens if it backs up more? Well, it will be in negative territory. Yet the 0 point could have been located a little bit differently. With a veritable system, on the other hand, once it is back up next to 0, the locomotive must change its heading in order to traverse to negative territory. To do this, it would either have to pivot at 0, or in more practical terms, enter into a circuit at that point, a sub-circuit at that point. Aside from a change in heading, the variable system can be used with a negative and the positive. When the negative and the positive are of different quality or substance, with the real system, the negative is only a lessening of the positive. The mere fact that it can handle negative square roots in a straightforward manner, which has long been a barrier to mathematics, should provide territory for the enterprising physical scientists to explore. After all, mathematics is the primary language of modern physical science, and the latter has difficulty traversing regions clouded over with intellectual imprecision. When a change of direction is involved, ask the question, is there one heading or two? For example, magnetism involves a change of heading divided by a zone of neutrality, does it not? Well, what other phenomena are like that? That is my speech. Thank you.
Unfortunately, we're